And welcome. Analysis of modeling and reasoning math questions, grade 8. We're going to start with this example. I just want to let you know, every time you see this small picture here, I recommend you pause the video and try to solve the question on your own, and then come back and check your work. This is a Ohio State Test Spring 23 question number 12. I'm given here a right rectangular prism. Right rectangular prism, all these angles are 90 degrees. All these angles are 90 degrees. Okay? So, and they give me some numbers here, and they're asking me to find the distance from A to B, or the length of AB. And I'm giving some options here. Okay, so in order to find AB, I know how to deal with rectangles, with triangles. I need to have this as a side of a rectangle or a triangle, so we can deal with it. So what I did here is I called this a C, D, and then I'm going to create a right angle triangle. That's the first one. And there's another one down. That's the second one. The second one, and I also put the information given to me. That's 12. This is 3, this is 4. And both of these are right triangles. Every time you encounter a right triangle, think of a very important theorem that is always on the test. It's called Pythagorean theorem. You have a right angle triangle, A, B, C, and A squared plus B squared is equal to C squared. So if you are given A and B, you can find C. If you are given A and C, you can find B. So anytime you have two of these three numbers given to you, you can find the third one using this formula. So now back to what we have here. This is a right angle triangle. This is 3, this is 4. I can find this AD, which is the same as this, which is the same as here. So I'm calling this X is an unknown. So I put my equation, X squared plus 3 squared is equal to X squared. Now, 4 squared is not 8. Some students, they make this mistake. It's not 4 times 2. It's 4 times 4 itself, 2 times. So that would be 16 plus 9 equals X squared. 25 equals X squared. So X is 5. So now I put 5 here. I move to the other triangle, call this Z. Again, we apply the theorem, Pythagorean theorem. 5 squared plus 12 squared is equal to Z squared. 5 squared is 25. Plus 144 is equal to Z squared. 169 equals to Z squared, and Z is equal to 13. So I go here and mark 13. Once you get the answer, check for whether it's reasonable or not. If by chance you made some mistakes and you got 5.0, and you think that you got the answer because it's one of the options here, look at this here. This has to be more than this for sure. So it can't be 5 centimeters. So always look for whether your answer is kind of makes sense or not. And here you see 13 is really good, really good. Okay, now an example 2. A cylinder is shown. Again, pause and solve, please. And the area is in square feet of this base is 9 pi. So I am given the area of the base, and they are asking me to find AB, the length of AB. Again, think of creating a right angle triangle. That's what I put here. So this is X. Now the area of the square, the area in square feet of the base is 9 pi. So I know the area of this here. Now from the area, I should be able to find the diameter. Once I find this edge here, this side, I have this, I apply Pythagorean theorem again and find X, the unknown. These are the options given to me. In questions like that, don't look at the options. Solve it and then see if you found one of these So this is my base. It's a circle. This is the radius, diameter, and the area of a square is pi r squared. So, and it's given to me being 9 pi. So now you simplify here and you get r to be equals to 3. So the diameter is 6. So this is 6, this is 8, and now it's easily, I can find X. 6 squared plus a squared is equal to X squared. 36 plus 64. 100 is equal to X squared. Then X is equal to 10. It so happens it's one of these options. 10, it makes some sense. It makes sense, okay? It makes sense being 10. Okay, so now we move on. I want to talk about transformations. Those are really important in the Ohio State test. A lot of questions about these issues here, the reflection, the rotation, the translation, and the dilation. So I'm going to remind you of the definitions of these transformations. Start with reflection across the x-axis. So that's your x-axis. If you have a point here, when you reflect the point across the x-axis, you get this one here. So obviously xy gives you x minus y. X stayed the same, y became minus y. Here is the reflection across the y-axis. This point here is going to be here. Okay, so that's the y stays the same, but x became minus x. Now let's see an example of this reflection. We're going to do across the x-axis. Now this point here, 1, 2, is going to go down 1, 2. This point here, 1, 2, is going to go down 1, 2. Here, 1, 2, 3, count. You count 1. Don't count over here, say 1, no. When you walk, you count 1, 2, 3. Come to this here is 1, 2, 3, 4. 1, 2, 3, 4. Join them. That is a reflection of this figure across the x-axis. If you take a paper like that and fold it across the x-axis, this will be matching this exactly. Now, what's the reflections across the y-axis? Now we're going this way. This way, again, the same thing. 1, 2, 1, 2. This 1, 2, 3, 4, 5. This is 6. See, that's 6. It becomes minus 6. This one here is 3. It becomes minus 3. You join them, you're done. Now, the rotation is a little bit more, I wouldn't say complicated. It's a little bit more complicated, yes. So this is a clockwise rotation. Clockwise is going to the right like this. It's going to the right clockwise. So this point here, AXY, is going to be this. It will be the image of this point by this rotation about the origin. So what happened is you have to create a 90 degrees here, 90 degrees here. So you see now the coordinate of this point is y minus x, y minus x. So xy goes to y minus x, and I will explain that a little bit more later. Here's the counterclockwise rotation. Now you're going now to the left. You're going to the left. So this point is going to be here. So again, you create a right angle here. So this point here is minus y, x. So xy takes you to minus y, x. We will return to this a little bit very soon. Now, here's what I want you to understand. If you remember this rule, you will not make any mistake. 90 degrees clockwise rotation. So we're going to the right. We're going to the right. Put your xy. Now, xy are going to be exchanged. Y is coming to here and x is coming to here. But one of them will change the sign. So you are going to the right. The coordinate that is going to the right changes the sign. Okay? Now, counterclockwise, you're going to the left now. You're going to the left. See, again, x, y are going to be exchanged here, y and x, but which one is, one of them is going to change the sign, the one that is going to the left, This way, you will not forget how to apply this. Now, just quickly, 90 degrees clockwise, 90 degrees clockwise is the same as 270 counterclockwise. So to come from this point to this point, you can do 90 degrees like this or 270 degrees like this. 270 degrees clockwise, if you go 270 degrees clockwise, it's the same as 90 counterclockwise. Okay, so just remember that is easy. If you are asking to do 270 degrees, I will turn it to a 90 degrees. It's easier to deal with. Now, let's see. This is a 180 degrees clockwise or counterclockwise rotation about the origin. This is the easy one. So this point, xy becomes minus x minus y. Okay? So 180 degrees, whether you're going this way or whether you're going to this way, it's the same thing. You get the same point. Now, let's see some examples here. 90 degrees rotations, examples. 90 degrees to the right. See, we're going here. Now, this is going to end up being here. Okay, be careful about that. So I'm going to find out the coordinates of these points. So A is 2, 3. B, 4, 1. C, 6, 3. D, 3, 5. Here's the rule now. We're going to the right. We're going to the right. Then x changes sign, y here. So now from this, you can find the images of the rotation. So E is 3 minus 2. See, 2, this becomes minus 2, this 3 here. See, y is 3, 1, 3, 5, 3, 1, 3, 5, and those are changing their signs. So that's E, F, G, H, joint. That is the reflection, that's the rotation of this figure, 90 degrees about the origin. Now, look at this. Straight line here, perpendicular. So I turn this around 90 degrees, 90 degrees. Now, let's see what happens if I do counterclockwise rotation. Okay, I put my coordinates here. I'm going to the left. Here's the rule. Going to the left, y is going to change sign, not x. So now easily, you can find w, x, y, z. You draw them the same as we did before, and that is the other one. Now look at the, again, this line here, perpendicular to this. This line, perpendicular to this. Now, if you do rotations of 270 clockwise here, you get to here. If you do 270 counterclockwise, you come to here as well. So 180 degrees rotation, this is easy. X, y goes to minus x minus y. And see in this case how this one and this one are parallel now, Now, dilation by a scale factor of k greater than 0, centered at the origin. So if k greater than 1, AXY is going to go to A prime, a KXKY is going to go out. It's going to go outward. When K is less than 1, this point is going to go inward. Let's see how that is going to go with, let's see this example. Dilation, scale factor 2. All of these are going to be multiplied by 2. The A will be 2, 4. 2, 4. B will go to -6, -4. C will go to 6, -2. Join them. This is the dilation. The factor of 2 is larger, is bigger, factor of 2. Now let's see factor of 1/2. 1, 2 will be 1/2, 1. -1.5, -1. 1.5 minus 1/2. Join them. It's shrunk. It's smaller. It's smaller. Now, translation is really the easiest of all of these transformations. It basically you are shifting the figure down or up or right, left or right. So here we are going to translate A, B, C, D, 10 units down and 6 units left. 10 units down. So from this point you count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing here, you go down 10. You go down 10. You go down 10. Now, we did that down 10 units. Now we need to go 6 units to the left. Again, take this one here. 1, 2, 3, 4, 5, 6. Do the same thing for the rest of them, and you get this. So from here, down 10, 6 to the left. Here's something to remember all the time. Only dilation changes the size of the figure. Only dilations. It makes the figure bigger or smaller, but it will look exactly the same as the first one, okay? All other transformations change only the location of the figure. Now, example number 7, Ohio State Test Spring 23, question number 14. Similar parallelograms EFGH and PQRS are shown. What sequence of transformation can be performed on this to prove that the parallelograms are similar? Okay, so I'm playing with this small one. Okay, I want to see what happens. Now, this small one, it's going to end up being this. So there is some dilation somewhere for sure, okay? So that's why you see the dilation. Okay, there is some dilations happening here for sure. Now, let's look. In this kind of questions, you have to read those and see what options do you have, and then you have to prove what you chose. I mean, you have to make sure you make a good choice. So a reflection across the x-axis and then dilations by a scale factor of 3, that's a possibility. I'm not sure, I have to check it out. Here, a reflection across the x-axis and then a dilation by a scale factor of 1/3. That means you are making it smaller. That's impossible. This here is not a good choice. Gone. Not this one. Let's see. We talked about the second one. Let's delete this here. No, the A is still a good option. This one here is not a good option. Let me see here. This one here is not a good option because 1/3, that means you are shrinking it. This is not shrinking, just making it bigger. 180 degrees clockwise rotation about the origin and then a dilation by a scale factor of 3. That's a possibility. This last one, a 180 degrees clockwise rotation about the origin and then a dilation by a scale factor of 1/3. That is impossible. Okay, so this one is not an option either. So now you have 2 options. You can't just guess, like you have 50% chance to guess it right, but you need to do the work. So let's try to see this option A, if that is a good option for me or not. A reflection across the x-axis and then a dilation by a scale factor of 3. So let's do the reflection. That's A, that's your E, F, G, H. Those are your coordinates. The reflections will give you, see, X does not change, Y changes, because you are making a reflection across the x-axis. So you have that one here. Okay, that looks kind of promising here, because obviously if I dilate these 3 times, I'm going to get this. So what is P, Q, R, S is this, and you notice now 1 times 3 minus 3 times 4, 3 times minus 4 minus 12. That looks like a dilation by 3. So I got it. This is the good option. This is my answer. Now, if by chance you started looking at the other C to see if it's good or not, so a clockwise rotation about the origin and then a dilation by a scale factor of 3 centered at the origin. So when you do the calculation here to do the rotation, clockwise rotation 180 degrees, you get to this point. See that 1, 4, minus 1, minus 4, minus 2, 4, 2, minus 4, okay? XY takes you to minus X, minus Y. So you get this. And when you look at this, you cannot really dilate this and good this, because it will not give you the same look of the figure. So this is not a dilation. So my answer is a reflection across the x-axis and then a dilation by scale factor of 3. So you see what we did? We've canceled this because of this 1/3, and we canceled this because of this 1/3. And we're left with 2 options, and this happened to be the right option. If somebody starts with this, we found out that's not the right option. Okay. Example number 8, Ohio State Test Spring 23, question 33. Stella rotates A, B, C, D 90 degrees counterclockwise around the origin. Then she translates the rectangle to the right by K unit to create a rectangle WXYZ. One side of WXYZ lies on the Y-axis. Okay. Rotates 90 degrees counterclockwise. So this is going to be here. I'm going that way. I'm going to the left. I'm going to the left. Okay. So what is A, B, C, D? A is 1, 4. B is 2, 4s. Okay. We want to find A prime, B prime, C prime, D prime. The formula. We know that X, Y are going to change rows, but which one is going? One of them will change the sign. Which one is going to change the sign is Y, because you're going to the left. You're going to the left, and Y here is going to the left. So now just apply this rule here. You get minus 4, 1, minus 4, 2. Here is the result of the rotation. Now I go to the second thing. She translates the rectangle to the right, K unit, to create WXYZ. One side lies on the Y-axis. So when you translate, you are shifting it this way. If you shifted 1 unit, this will be here. That's a good answer. If you shifted 1, 2, 3, 4 units, this side will be here. So it's K equals to 1 or K equals to 4. That's very interesting example. Example number 9. I added this example just to make sure you understand the concept here, what we're doing in a different direction. Omar rotates A, B, C, D 90 degrees clockwise. Very important, around the origin. Then he translates the rectangle up K units to create rectangle WXYZ. One side lies on the X-axis. So let's wait on the second part of it. Let's see what happens when we rotate A, B, C, D 90 degrees clockwise. Clockwise, that means 90 degrees clockwise, we're going this way. This is going to be here, not here. Counterclockwise will be here, but it's clockwise. Clockwise is going to be here. Okay, so let's do the work. Find first the coordinates of the points A, B, C, D. The rule. Now I know X, Y again are going to be switched here. Now which one changes sign? We are going to the right. We are going to the right, so X changes sign. Now it's very easily to find those coordinates. That's it. Rotation 90 degrees. Now I want to shift this up so that this side be on the x-axis or this side be on the x-axis. Obviously 2 for this side to be here and 6 for this other side to be here. That's very interesting example. Now, Ohio State Test Spring 23, question number 20. Quadrilaterals E, F, G, H, and E prime, F prime, G prime, H prime are shown on the coordinate grid. These two here. Which sequence of transformation shows that the quadrilaterals are congruent? And you see here he's using the transformations are done on E, F, G, H on the original one, okay? E, F, E, F, E, okay. So now you have to read those. You have to read those. It says reflect E, F, G, H across the y-axis, reflected across the y-axis, then translate the image 5 units to the right. Reflect E, F, G, H across the y-axis, and then translate the units 5 units down. Rotate, and then translate, rotate, and then translate. Now, you need to kind of remember, if you are reflecting E, F, G, H across the y-axis, if you reflect this across the y-axis, this line here is going to be parallel to the x-axis. It's going to be here. Then there's no way that you can drop it to match this, because this one is not parallel to the x-axis. But let's see what happens if I reflect E, F, G, H across the y-axis, which covers these two options here. So let's see. Here's a reflection. And then whether you go to the right 5 units or go down 5 units, this will never match this, because these are parallel to the x-axis. This is not parallel to the axis. So this for sure is not an option. This for sure is not an option. So there is some rotation that needs to happen first. So one of these is the right answer. And you see that both of them rotate 90 degrees clockwise, but one of them translate 5 units to the right, one is translate 5 units to the 5 units down. So let's see what happens now. We're going to do now rotate 90 degrees clockwise. This is going to be here for sure. This is going to be here for sure, and it's clockwise. Coordinates of E, F, G, H. The rule, again, we are going to the right. We're going to the right, only X changes sign. You found this? All right, that is promising here. That is promising. Now, is it translate the image 5 units to the right? If you translate this 5 units to the right, it's going to take you this way. Will not match this. So this option is not correct. I'm left with the option rotate E, F, G, H 90 degrees clockwise, and then down 5 units. If you go down 5 units, this will match this. Now, this is an example that some students got confused with. It says that Christy drives from Columbus, Ohio to Cincinnati, Ohio. Match each graph to the quantity which would best represent the value of Y with respect to time, X in minutes during Christy's drive. So this is a time, and this here is either a distance or amount of gas, okay? Now, when you're going from Columbus to Cincinnati, when you start from Columbus, your distance from Columbus is going to be greater, it's going to increase. And your distance from Cincinnati is going to decrease. So you're going to Cincinnati, you're going from Columbus here. So you were 0 at Columbus, and then you started going to Cincinnati. So your distance from Columbus is going to increase. What happened to your distance to Cincinnati is going to decrease. And this is the gas. Obviously, you are using some gas here. The gas is going down. At one point, you filled up the tank. And I like this to be a little bit more straight, but anyway, that's fine. You lift up the gas and then you go down again. You are using your gas, okay? So that's the situation here. Now, I am going to remind you a few things about slope, because this is really important, and you see a lot of applications in the Ohio State tests using slope of a line. I think people are confused about the slope. Before you calculate the slope, you need to know whether it's positive or negative before any calculation. When you look at the line from left to right, if it's going down, it's a negative. The slope is negative. If it's going up, or again, looking at it from left to right, if it's going up, the slope is positive. Horizontal, slope is 0. Let's see how we can use this. This is the slope formula, famous formula, y2 minus y1 over x2 minus x1. This is called the rise, this is called the run. Now, find the slope. All right, this is before I do that, I know it's negative. So I need to pick up 2 points on the grid, okay? 2 points on the grid. So here I picked up this point here, and I picked up this point here. There are some other options in this example. So here's your rise, here's your run. Now, if you're coming from here, you are coming from here to here, you're going down, that's negative, right? That's positive. That's why you get a negative answer. So rise, run, I know it's negative 5 over 8. So look at the distances, 1, 2, 3, 4, 5, and 8 here, 1, 2, 3, 4, 5, 6, 7, 8, and I know it's negative minus 5 over 8. If you want to use the formula, that's fine. Put the coordinates of these points, A and B. Call the first one x1, y1, the second one x2, y2. Apply the formula, you get negative 5 over 8. On your own now, again, pause and solve. Find the slope. I know it's positive before I do any calculation. Pick up 2 points. I picked up these 2 points here. Rise is 3, run is 10, 3 over 10. You want to use the coordinate, the formula, it's fine, you can do that easily. And you find answer to be the same, 3 over 10. Example number 14, Ohio State Test Spring 23, question 31. Create an equation for the line that passes through 2, 4, and 3, 6. You're allowed to have a graph paper, so I would draw these points first. Draw them first, and let's draw the line. And I see I'm lucky here that the line goes through the origin. Okay, so what is the slope of this? I know it's positive, it's going up. So that's 2 over 1. The slope is 2. And this is the equation of a line, y equal mx plus b. B is the y-intercept is 0 here. Then your equation is y equals to 2x. And you're done. You got it right. Now, before you move on, I'd like you to check your answer. How do you check your answer? Take this point here. Put x2 here. 2 times 2, 4. That's the 4. Take the 3. 2 times 3, 6. That's 6. Now, if you don't have a graph paper and you want to solve this problem again, you can just call this x1, y1, this x2, y2. You can do either one. It doesn't matter. Either one of them, you can call it x1, y1. So now the slope formula, I get 2 as a slope. The y-intercept formula is y equals to mx plus b. M is 2. I know is 2. I put it down here. I need to find b. How do I find b? I can use this point or this point. So in this example, I use 2. So if I put 2 here, I have to put 4 here. So this cancels this. The b is equal to 0, and I get the same answer. Another example, line equations. Create an equation for the line that passes through 1, 4, and 3, 6. I draw this here, and I'm also lucky here because it passes through this point here. This is very similar to the previous example. The slope is 2 over 2 is 1. So you get this answer here. You can always check your answer. When x is 1, 1 plus 3 is 4. When x is 3, 3 plus 3 is 6. Another example, create an equation for the line that passes through 1, 5 and 3, 2. Okay, if you draw it, you get this kind of figure here. Now, I know the slope is negative. It's going down. Now, I can't really guess this point here. I have to do some calculation now. The slope is, here's the ratio, 1, 2, 3, 2. And negative minus 3 over 2. Formula, replace the m. Use one of the points. I use this here. And I get b 13 over 2. Here's your answer. And then you can check it. You replace by 1, you get 5. Replace x by 3, you get 2. Ohio State Test Spring 23, questions 34. This is a very, very interesting example. A graph passes through the points 0, 0, 1, 2, and 2, 5. Which statement about the graph is true? So now you have to really read all of this here, okay? One of them is true. That's what he's asking you, which statement. It is linear because the graph passes through the origin. This is your origin, 0, 0. And it claims it's linear because it passes through the origin. Has nothing to do with being linear passing through the origin. You can create a very simple here. That's not linear and it passes through the origin. So that's not an option, okay? That's not an option. It is not linear because the graph passes through the origin. That has nothing to do with passing through the origin of being not linear. Because here's a graph that passes through the origin and it's linear, okay? Okay, so that's not, so, but it's not, it says it's not linear because the graph passes through the origin. No, if the graph passes through the origin, it can be linear, it can be linear. So this option is not acceptable. Now, it is linear because a straight line can pass through the given points. That might be a situation here. It is not linear because a straight line cannot pass through the given points. This one is opposite to this one, so one of them should be right. So now we have to do some calculation, okay? So let me clean this up a little bit here so we don't have this here, okay? Okay, I'm drawing these 3 points, and if I draw a line between these two, or between these two, let's do between these two, I see it's not passing through the third one, so this is my answer. My answer, it's not linear because a straight line cannot pass through the given points. Now, if you are not sure about your drawing, from here to here, the slope is 3 over 1, 3. From here to here, the slope is 2. They are not the same. So these 3 points are not on the same line. So we got this taken care of now. So it's not linear because a straight line cannot pass through the given points. A follow-up question here that I added here: what possible translation to one of the points to make the line pass through them? I will let you solve it and come back, and you will find you can have either translate A 1 unit down, or translate C 1 unit down, or translate B half unit up. This is example question number 36. A scientist recorded the temperatures of 2 different liquids as they were heated. The results are shown in the table and graph. Table and graphs are always on the test, on the Ohio State test. This is a table, this is a graph. You need to understand what you are given here. So they're asking you which statement is true. Again, you have to read those first before you do further investigation. Liquid 1 heated at a slower rate than liquid 2. We don't know yet because I don't know the rate yet. And had a higher starting temperature. This is liquid 1. This is the starting temperature is 18. This one, the starting temperature is 20. So this one is not higher than this. So this option is gone. Liquid 1 heated at a slower rate than liquid 2 and had a lower starting temperature as a possibility. But I can't say confirm yet, okay? Because I haven't calculated the rate yet. Liquid 1 heated at a faster rate than liquid 2 and had a higher starting temperature. Again, that is not acceptable. So I'm left with this one and this one. I have to do some calculation. I have to find the rate of the of both liquids. So here we're going by 5. Here we're going by 17.5. 35 minus. So the rate here is 3.5. This one here, and they were nice to giving you this point to start with this point. We could have started with this point, but they gave you this point anyway. So that's 60. That's 80 minus 20. That's 18. 18 minus 0. So the rate here is 60 divided by 18 is 3.3 repeated. And obviously this one is higher than this. This one is higher than this. And the starting temperature is less than this. So liquid 1 heated at a slower rate? No. Liquid 1 heated at a faster rate and lower starting temperature. That's it. Now you're sure that you got the answer 100% correct. A convenience store has 20 bottles of water. Each day, a supplier delivers the same number of bottles to the store. Same number of bottles to the store. The store does not sell any bottles of water for 3 days and now has 110 bottles. What is the rate of change in the store's supply of bottled water each day? So you started with 20, and now you have 110 after 3 days. So that is really simple. 110 minus 20 divided by 3 days. 3 days. And you get 30 bottled water every day. This is another example. A teacher compares the masses of 2 samples of different liquids. The equation M is equal to 0.674 V models the mass M in grams G of liquid ammonia. The variable V is the volume in milliliters ml. The graph shown represents the relationship between mass and volume for hydrogen peroxides. So here he is giving you a formula and a table and a graph, okay? And this is what he's asking you to do. Select words or phrases to complete the statement to describe which sample of liquid has a greater mass. The sample of, and you have options here, ammonia or hydrogen peroxide, has a greater mass because it has the greater, it gives you here volume, unit rate, initial value, okay. So we need to do some calculation here. Start with ammonia. M, the mass is 0.0674 V. V is the volume, and he's comparing 10 milliliters, okay? He's comparing 10 milliliters. So you put 10 for the volume, you get mass is 6.74 for 10 milliliters, milliliter of volume. Okay, so V is 10. So now if I take the other one, hydrogen peroxide, it's, if you look at this here, this is the mass, this is the volume. See, 10 is 10, when 20 is 20, when 30 is 30. So the mass is 1 V, is equal to the volume, okay? Now when V is 10, obviously M is 10. So obviously now this one is larger than this. This one is larger than this, the mass, for the same amount of volume. So the sample of hydrogen peroxide has a greater mass, it's 10 here, 6 here, for 10, the volume of 10. So why, look at here, the unit rate is 1. Here, the unit rate is 0.674 because it has a greater unit rate. Now, this example is very interesting. It says Mr. Miller presented his class with the following equation. What are possible values for P and Q? To solve a problem like this, the easiest way to do is look at this number times this number should be equal to 1.5, and then 10 to the power 4 times 10 to the power Q should be equal to 10 to the power 8. So we're going to be using this formula here, power formula. So the first thing is 7.5 times P equals 1.5. The second one is 4 plus Q equals 8. Easily now you can find P to be 0.2 and Q to be 4, and you got a full mark for this question. Now, there are some other options. Actually, there are an infinite number of solutions. Let's find one of them. If I take 1.5 times 10 to the power 8, which is the right-hand side, I can multiply this by 10, divide this by 10. So it'll be 15 times 10 to the power 7. So if I replace this by 15 times 10 to the power 7, now I use the same technique I used up here. So 7.5 P is equal to 15 now, and 4 plus Q now is equal to 7. You get P is 2 and Q is 3. So actually there's an infinite number of solutions. That's good. Example number 22, a cylinder is shown. What is the volume in cubic meters of the cylinder? When there's a question involving a cylinder, they will give you the volume, okay? It's the base times the height, pi r squared times h. Now, this is, I mean, if you look at 6 and you say, okay, 6 times 10, 60, it's wrong. So some of these answers are kind of misleading, okay? So you need to use the volume, you need the formula, you can't guess it like this. So we're going to get the volume is base times height. Base is pi r squared. R is, you have to use the 3 here, not the 6. if you use the 6, you get this answer, you get something else. So if you use the 3, so you get b is equal to 9 pi, that's the base, times 10 the height, you get 90 pi, and that's your answer. If you use, instead of 3 here, you use 6, you will get here 36 times 10, you get this answer. You think that you got it right. It's not right. You have to use the radius here. That's why it requires some thinking, okay? Another example, a cone is shown, the volume of the cone is 100 pi in cubic feet. Adam calculated the diameter to be 5 feet. Read the question correctly, the diameter. What mistake Adam made and what is the correct value of the diameter? Again, they will give you also here the formula. Now, just remember that a cone is 1/3 of a cylinder, okay? So that's the diameter down. That's what we are trying to calculate. So now, 100 pi is given. That's the volume, is equal to 1/3 pi r squared times the height is 12. 12 divided by 3 is 4. Simplify. You get 25 equals to r squared. R is equal to 5. So the diameter is 10. So Adam calculated the radius of the base, not the diameter. Okay? This is the last question. A diagram is shown. Create an equation for z in terms of x and y, as a function of x and y, in terms of x and y. Now, this is an exterior angle. These two are interior angles. Now, there is a rule. If you remember it, that's great. It says the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So this is equal to this plus this, okay? So you just put z equal to x plus y and you get a full mark for the question. If by chance you don't know this formula, let's call this here w. So now you have x plus y plus w, those are 180 degrees. That's the sum of angles in a triangle. And then you have z plus w is equal to 180. So now, obviously, z is equal to x plus y. That's it for today. Thank you, and see you soon.